Hi everyone, just wanted to take a minute to talk a little bit about graphing quadratic functions that are in factored form, or if they're not in factored form, how you can put them in factored form, and then graph them. All right, so let's just quickly remind ourselves what is factored form. So factored form is going to be this particular setup where you have A, which is still going to determine, open up and down, how wide or narrow it is, and then x minus p times x minus q, where p and q are your x-intercepts. As a reminder, last time we talked about how the vertex, the x value of the vertex is going to be this. It is going to be p plus q divided by 2, right? You average p plus q, or you average p and q, I should say. Sorry. And then to get the y value of the vertex, you just plug in whatever you get. So let's say you get 3, plug it in, solve for f of x. All right, or f of 3, I should say. All right, so let's go over graphing. You probably would pick up on this, but there's a couple steps you could follow. So first and foremost, you'll notice this problem that we're looking at here. You're not actually in factored form. You're in standard form. And you do know how to graph in standard form, right? You kind of have to find the vertex, which is negative b over 2a. But let's say you don't feel like doing that, and you kind of want to kind of get away without doing the negative b over 2a because you don't want to. So step one of graphing is going to be that you factor if needed. So essentially what you can do here is if you look at this, just this part, right, you know how to factor this. Right, so you're going to use the AC method. A times C is, A, oops. Let me go to the next page. I have more room. So if you're just factoring this, you're just going to look at this and you're going to know that, you need A times C. So 1 times negative 8 is negative 8. Now you need factors of negative 8 that add up to negative 2. What adds up to negative 2? Well, that would be negative 4 and positive 2. So this is going to be what you have. That right there, that factors into x minus 4, x plus 2. And just to confirm, right, if you multiplied it out, x times x is x squared, x times 2 is 2x, negative 4 times x is negative 4x, negative 4 times 2 is negative 8, right? And that'll simplify exactly to that. So after you factored it, you get x minus 4, x plus 2. Don't forget, you have to do a times c. So if you had like a 3 in front here, you would have to do 3 times negative 8 and then find factors of that. Luckily, in this case, we do not have that, so we're not going to worry about it. So once you factor it, we are going to deal with it later. Don't worry. Maybe not today, but a later day. So once you factor it, you can just rewrite it, right? X minus 4, x plus 2. You'll notice when nothing's in front, that means a is 1, right? So if nothing's out front, a is going to be 1. The only time you're going to have an a out front is essentially if you have a GCF, right? So like if this was 3x squared minus 6x minus 24, right? You can factor out the 3, and then the a would be the 3. But in general, unless you have a GCF like that, you're not going to factor it and end up with an a. Okay, so now you need to find your roots. Roots are just another way of you saying x-intercepts. So, right, we had this. Based on what we know, when you have a minus, that is just the root. So you have this, right? You have x equals 4. And here, this is the opposite, so it's x equals negative 2. So look at that. You have 2 points. Right? Unfortunately, they are reflections of each other across the axis of symmetry, so it doesn't necessarily help you in, getting an extra point. It's not like you get 4 points from this. You really just get the 2 because they are their own reflection over the axis of symmetry. All right. That being said, that does mean that we can now figure out what our vertex and axis of symmetry are. So as a reminder, to find the vertex, what you're going to do, right, you have f of x we just rewrote it like this. Okay, we rewrote it like that. We found, 4 and -2, so we're going to find the average of these. So 4 minus 2 over 2, this is going to be your x value. It's 2 over 2, which is 1. So now to find the rest of the vertex, I have to plug in 1. So I have f of 1 equals 1 minus 4. That was 1 plus 2. Now, plus. Whoop. I will say the one benefit to this too is you don't have to square anything. You really just end up with like some pretty simple math once you plug it in. So 1 minus 4 is -3. 1 plus 2 is 3. So you get equals -9. Okay. So your vertex is going to be 1, -9. Now, additionally, that does mean that your axis of symmetry is x equals 1. Right. So we already did find what happens when I plug in 4 and -2. Right. So now later on, when we're picking points, we want to pick points that are close to it that we don't already know. So if the next number over happened to be like one of the roots, don't try and plug in the root when you already know the answer. All right. So now find another point. When in doubt, right, we know the axis of symmetry is x equals 1. So just plug in a point, plug in 2, right? If I plug in 2, that's a close point. Plugging in 2, which is only one value away, is the same as plugging in 0, right? So in fact, I'm going to make my life even easier. I'm going to just plug in 0. Well, we already know what that is. That's just the y-intercept, right? You cancel out 0, 0, -8. Okay, so you end up with 0, -8. Now, because that's the same thing as 2, that means you have 2, -8. All right, so just to recap, what have we found? We found the vertex, we have found the x-intercepts, and we did find an extra point just to kind of bring out the curve. So then what you're going to do is you're going to plot. So I'm just going to pull that up really quickly. Now, just for the sake of this, if you look at it, f of x equals x squared minus 2x minus 2x minus 8, you will see here's our parabola. Now, I'm going to hide that real quick. Let's add the table. So remember, we found our roots. That was going to be, when we factored it out, I'm going to call it g of x. It's the same thing, but I'm going to call it g of x equals x minus 4, x plus 2. And if you turn that on, see, that's the same thing. But I am going to shut that off. All right, so we have 4 and 0. We have -2 and 0. When we found the average of that, we found that it was 1. We plugged that in, we got -9. And we found another point, right? We did find another point. When we plugged in 0, we got -8. And 2 was the same thing as that, so -8. All right, so if we graph that, you'll see the green still on them. Additionally, if you graph the red, the green is on them because they're all the same. All right, now kind of using this logic as well, you could also kind of write the equation based on for the graph, right? So this is your intercept, right? You have x plus 2. This is your other x-intercept, x minus 4. And then it's just a matter of finding a. So you just kind of plug in a value and solve for it. You can solve for a. All right, but ultimately that is how you're going to deal with graphing. Let me know if you have any questions, and have a great day.